Okay, so we just finished off talking about CRUD with JDBC. I really would like to cover the PowerPoint stuff only so that if there's anything where any kind of cracks we need to fill in, that's what I want to use the PowerPoint for in this particular chapter. So again, I have it in, I was kind of building it up in chapter 11 and chapter 10. That's where I had it, should be chapter 10. I kind of was talking about it in chapter 11. I'm going to go over it and then I'll try and upload it later on. It's quite big. Actually, the PDF is 21 megs. So I'm gonna see if I can optimize it before I upload it. It's pretty big. A lot of images basically. Okay. So let's take a look at this thing. So one of the major things they talk about in the book is the idea of SQL, so structured query language, and how it works with our stuff. One of the other things they talk about that I didn't cover is the idea of a Rowset. Okay. It's another methodology for us to read and write, okay, into the database, okay? So not that you couldn't use a Rowset. I prefer using my method because it's more, I can do more with it, right, than I'm used to doing with the Rowset. The other thing we didn't cover at all is sometimes what you can use is, you know, kind of functions on the database itself that you can use, right? As opposed to functions on the client side, right? We're making methods on the client side to do, full CRUD. You can use methods that are built in, the functions that are built in on you've written on the database side to do some of the work for you as well. So there's different ways of doing this thing. Okay, different databases that you can connect to with JDBC that we talked about, like for example, Oracle, Microsoft SQL. I know Ilya is a big fan of Oracle. You know, that's what he was using for his examples. MySQL is one of the most common ones out there, especially if you're a PHP person, right? They don't have Mongo here as a NoSQL database. Postgres is very popular as well because of its security features, right? It's a little bit more secure than MySQL. Same kind of idea. Some differences in the way it works. DB2 is definitely an older system, phased out, but still in use all over the place as a legacy system. If you learn DB2, I'm not sure you guys learn DB2 here at all at Centennial. I know we learn it in other colleges as well, but it's one of the ones that is still being used by the banks, believe it or not, and government, right? Even though it's old. So different database systems. And again, we talked about using a driver. The driver that we use, right, is the driver that we first loaded. When we first did our configuration, right here, when we did our reference to our driver, remember we had to make this MySQL connector driver. Each time you access a different database, you need a driver. So again, if I had multiple databases that I was connecting to with one application, or if I wanted to test multiple databases, I would need multiple drivers. Okay, one driver per database. And each manufacturer has their own. Okay. I'm not going to talk too much about that. And the books, they have an example in the book about the books database. I'm not going to go over too much about what that is. One thing they do is this whole idea of an entity relationship diagram, similar to what you got on your assignment. So your assignment 5 actually has an entity relationship diagram of a sort. It doesn't have one-to-many and many-to-one kind of relationships like it has here, right? And also, we don't talk too much about, we haven't talked about foreign keys here so far, right? Which is like an inner join. We haven't talked about that at all, right? In our little discussion right now. I want to show you that piece and how to do an inner join with the way they show you. And then you can tell me, maybe you have an idea of how you would do an inner join. You can do it by code again, by programmatically taking care of it. It's not that difficult to do if you think about it. All right, so we just saw a bunch of these statements here. So this is standard SQL, from, where, group by, order by. This one, inner join, and then this is the one we haven't covered, merges rows from multiple tables, right? So when I have a foreign key, as an example, right? That's what this does. Insert, update, delete. So the one we really didn't cover is this inner join one, okay? You're going to need something like this for your assignment 5, okay? Because assignment 5, if you notice, it has multiple tables, right? And I'll bring up assignment 5 in a second so we can look at that. Let's take a look. So we've learned about JDBC now. We should know a little bit. Take a look. Well, here we have it. We have three tables. And remember, the whole idea of assignment 5 is to show us which games you've been playing, for the semester, right, kind of thing. And what it's supposed to do is, it's supposed to be basically say is you should populate the table game with the titles of the games that you played, or maybe titles of games that you've ever played, or whatever, right? You're supposed to insert game and player information into the database. That's two different tables. There's a game table and there's a player table. Then there's a player and game table that kind of handle that have a kind of use foreign keys, the game ID from the game and the player ID from the player to create this inner join for this particular table for player and game, right? So be careful. That's one thing that you'll be asked to do. So update the existing player information. We know how to do an update, no problem. That's on the player side, on the player table. You do, again, how would I set this up? If I was going to do this assignment, I would set up a schema or model for the player, just like we did, which would be a player Java bean, right? I would do a game Java bean for the game information, and I would do a Java bean for this one too, right? 3, 1 for each table, right? And each of my SQL statements would work specifically for the tables that I'm affecting. Okay. You're going to be displaying reports with the player and played games information, right? So this stuff, the stuff that comes from this table. Player and game information is where you're going to get your reporting, right? And it says you may use Java FX components to display the reports. Notice how I didn't say you must use, all right? So if you really want to use Swing, I'm okay with it, okay? I'm not going to force you to use Java FX if it's too hard, right? And especially since the book makes you use Swing, it's all they use in the book because it's that chapter, and they haven't covered Java FX in the book yet when they do JDBC. It's kind of the chapter after, right? So it's okay. If you were going to use Swing and you said, you know what, Tom, I couldn't do it with Java FX, couldn't figure it out, I want to use Swing, I probably would accept it. I prefer you to use Java FX because the assignment says Java FX, right? So, in terms of marks, I would allow it, but you probably wouldn't get full marks, right? As long as you have a UI of some sort, you're going to be okay, all right? But you won't get full marks unless you use Java FX. Okay, allow the user to select the player ID. So how do I select the player ID? So again, it would be, okay, I want this player. I want all the data for this particular player. That's what I'm getting. So what is his stats? How many games has he played or she played, right? So think about how you would put together a, when it comes to player and game, you're accessing this main table. This is, if you notice how it's in the middle, this main table is what you want, and you want to access games and you want to access players based on maybe a drop down, right? And it says use prepared statements to implement all database operations. Well, yes and no. Prepared statements would work for most database operations because there might be some, like for example, display all rows, like we did that. When we did that display all rows, you don't need a prepared statement because you're displaying everything. Select star from movie list. Remember, there's no prepared statement that's necessary there. So that's kind of overkill. So you could use a statement for that one, and I would accept that. But for everything else, makes sense that you would use prepared statements because you're going to have this interpolation, right, happening for some of your choices. Now, in terms of detail, the program, the assignment doesn't give you a lot of detail to go on. Like you can make this happen in many different ways, right? When you create your views, your screens for all the stuff, there could be many screens you can make, or one big screen. I didn't tell you how to do it and say make 5 screens, 1 for this, 1 for that. You can, I've got submissions where I have one big screen that does everything, if you really want to. It's kind of weird, but it kind of meets as well. Meets requirements. So I didn't tell you how to do it. Okay, so that's what's required in the on the assignment. Now going back to this, so you need to understand about inner joins a little bit, and you should have learned that in your other database courses. Anyone not know inner join? Like that is like standard stuff, like database 101. We would do that in any database course. Okay, so they give you ideas of what a select statement would look like here in the book. So if you can always refer to the book if you want to when it comes to this kind of stuff because it's very similar to what we've done. Same thing with the where clause. You know, select column 1, column 2, whatever from table name, whatever the table name is, where, you know, a copyright is greater than 2013, or where rating is greater than or equal to 3.5, you know, whatever, for the way we did it, right? So the where clause. In the PowerPoints, they go over details about what it would look like to, you know, to structure your SQL query itself, how to structure it. And this is kind of a review of maybe what you've seen in other courses, you know, order by, last name ascending, last name descending, and so on, all those different clauses. Okay, here's the one where you need to understand the whole inner join idea, right? So again, it says database designers often split related data into separate tables, player and game is a good example, right? And it's necessary to merge data from multiple tables into a single result. And this is referred to as joining tables together, inner join, right? And what we do is we merge rows from 2 tables by matching values in columns that are common to the tables, right? So example would be select column 1 and column 2 from table 1, inner join table 2, this is just the query statement, on table 1 dot column name equals table 2 column name, which means that table 2, the table 2 column name is going to be the foreign key for that's going to be listed in table 1, and you want to share the ID. Typically, is what you want to share, the ID of the other table, right? Where you can do a lookup. So you don't want to have a different ID, you know, so that you can do a lookup for that particular. You could read that other table information, right? That's what you're going to try and do. Again, the on clause, it says specifies the columns from each table that are compared to determine which rows are merged, right? So again, I'm choosing column 1 and column 2, and I'm on table 1, column name is equal to table 2 column name, whatever the column name is. So for example, table 1 might be game ID, table 2 might have also something called game ID and their equivalent. That's what you do to make that inner join happen, okay? And here's another example. So the following query products produce a list of authors accompanied by ISBNs for books written by each author. So again, you have select your first name and last name, ISBN from authors, that's the authors table, right? Inner join, author ISBN, that's the table that you're looking at, right? The other table, and you're going to say on author's author ID with author ISBN author ID. Notice that they're the ID that you're matching, not another column. And then order by last name, first name. So that's the way you're doing it. Another example. So how would you do it for movie list? If I had, let's say, for example, I had, what kind of other things could you have? Could you think about other tables that we can include in our own little example here that would make sense?
Directors.
I could have directors, but think about the fields we already have, right? So we have some fields or columns we have already, and I want to be able to choose from a set number of options as opposed to some random options, right? So what would I do? So how about genre, right? Genre might be the easy one to do. So you might have comedy, sci-fi, blah, blah. Now notice that some genres are mixed. Like you have mixed genre, like, you know, comedy, sci-fi, or mystery, western, or something weird like that. You know, like fusion, genres that are a fusion of different things. And they have those these days. So you probably create a big genre list of different genres to pull down, right? So now you'd have a genre ID, right? And then that genre ID would refer to the ID of the genre that you're picking, right? Inside your movie list, you'd also have a genre ID. That genre ID would relate to, you know, the separate table for genre, right? That could be one. The other one could be, if you really want to be specific, rating, right? Maybe you want to make a rating table from, you know, that has a rating itself and a description, right? So the description would be like, you know, really good movie, or this movie sucks, or whatever. You can make, you know, kind of a rating table, right? That could be it as well. And like you said, directors would be another table. Choose a director that did the thing, maybe because there's only certain sets of directors. The release dates for the, you can have a release date, but that release date's kind of funny because you're choosing a specific date. You'd have almost like a calendar, if you will. But But those kind of things, you can make it so that it relates to the information you have. And what you want to do is you don't want to replicate these things, right? Especially if you want to do a pull down. And a good example is this: if you have a address information. So I have a contact list, let's just say, right? This is a typical example that I always play with, right? I have a contact list. In my contact list, I have a set of provinces, right? Or, you know, in the states, it would be states, right? So you'd have a province table. And the province or state table, you'd have all the provinces and states listed in. You'd have the province ID or state ID, and then you'd have your province description, province code, and province description, right? Long name, you know? And that would be a separate table from your actual address itself, the address itself, right? And then you'd also can have a set of, if you really wanted to, you could set up a set of postal codes, because there's only so many postal codes that exist in Toronto, whatever, or in other countries, other cities. Okay, so examples of foreign keys or in the inner join. Inner join is really important. You have to really understand how this is done, and we can talk about how would I make an inner join, right, for a table? How would I do a lookup, you know, for a table? Now in a UI element, it's no problem. It's just me like doing a pull down, right? So that element itself, when I convert it into a you know, a form, when I look at, let's say for example, my genre, it'd be a pull down. I pull down the genre as opposed to me typing it in. I would never type the genre in because it would be from another table. That's where it would come from. So that would be a pull down, and that pull down would specify the information that I would put into my my final results, if you will, for my movie list. So movie list would be a compound table made up of other tables that would join with that one, right? Okay, so insert statements we've talked about. I'm not going to go too much into that. Insert authors, and notice how they have the same syntax, first name, last name. We did that in our own. When you first saw that, and if I look at the movie list controller, let's go there for a second, and let's take a look at the insert for a second, right? So here's the insert statement. Let's take a look at our insert statement. Insert into movie list, and now we have in round brackets, we have a list of columns we're affecting and their values. Here we have a list of columns we're affecting, first name and last name, and the values, Sue, red, as an example, right? But instead of actually putting fixed values in here, we're interpolating with a prepared statement. Okay, same thing with the update statement. We've talked about that. And the delete statement, pretty simple. You know, from, table, delete, where, criteria meets whatever it is, like ID, where ID is equal to question mark, whatever the ID of the row is. Okay, they use a JTable, again, in the book to talk about how they do manipulation, database manipulation on the book itself uses, again, a JTable. One thing they also use is they also talk about Derby, right? Which is, you know, the built-in Java Derby that comes with, like I mentioned before, with your Java SDK, right, or your JDK. I don't recommend it. It's hard to kind of put that together, and that's why we've used MySQL, and MySQL is a more realistic kind of you know, database to use, you know, with Java. Okay, so let's take a look at this. So if we were to look at our connections here, we have the same kind of formatting. Notice we still use this try with resources. That's what they call it here in the book, try with resources. This complex try, where you have your connection, your statement, and your result set inside this try with resources, or, you know, enhanced try, right? Notice we also have our database URL here because they don't have my config class. Here they're using JDBC for the database type, Derby, sorry, for the database protocol, JDBC, Derby for the database type, and books for your table that you're connecting to, the database itself, right? So we did that in our config, our DB config. We do all that. We do this driver manager get connection, where we send in the connection string, the username, and the password, and the connection string being JDBC. Again, the protocol, MySQL for the database type, and then MovieDB for our database that we're affecting. as we're doing all this kind of stuff. And we also created this display exception, a special custom exception codes for to split off our exceptions for our SQL problems. That's what we do here. So again, they don't do that. They kind of do it inline. So they said connection is equal to driver manager.get connection. We use dbconfig.get connection, which is very similar. We just wrote it so that way we don't put in our username and password every time. And then they have a result set metadata. This is a different way of doing it, where what we're actually doing is they create a metadata object that gets the result set of the metadata and puts it into the metadata itself. And using metadata isn't bad. It's what you do is it's like doing the whole Java Bean idea with metadata. So you're getting basically an object that has everything, right? And then what you can do is you can manipulate the metadata information. So you can do things like how many columns do I have in my database? Well, I can say metadata.getColumnCount, right? Which is kind of neat. So again, there's some advantages and disadvantages to the way I did it, right? But there's some really good, clear examples in the book of other ways you can do it, right? So again, it says for every column, right? What you want to do is you want to printf, so a formatted print to the to the console of metadata.getColumnName. So you kind of make the column names come out, right? So the column names almost be like that would be your header row if you're going to print that. That's what this metadata stuff does for us. And now we use the result set. So while there's a next result set, just like we did last time with our read all rows, right? Then we're going to use a for loop that's going to go through each of the columns, and inside the same columns, just like they did the first one, they're going to take the result set and they're going to use the generic get object for each of the columns, right, and each of the rows, right? So again, that's what they're going to do. So they're going to get the get object instead of how we did it. We said get string, and we're going to get string at a particular column, right? They don't do it that way. They're going to do it based on column ID, right? Cool. It still prints out everything. It just does it in a different way. Notice how it says auto closable objects. Close methods are the methods that are called now, because all the auto closables are inside of the only ones that are allowed to be inside of our try with resources block, right? Those are the ones that can close. So you can't put in you can't be calling a method or an object that doesn't have the auto closable or the closable interface. If it doesn't implement the closable interface, it won't work. It'll give you a syntax error. Okay, cool. And then of course we do this whole catch block with a SQL exception where they do in the book they do a print stack trace. That's the way they like to do it with this SQL exception error. And again, this is the output of that. So notice how it's ordered in columns. We didn't order ours in columns, and you wouldn't, right? When you're using a UI, you wouldn't care about this for loop. This wouldn't do anything for you, right? What you'd want to do is what I'm telling you to do, which is you're going to get the information as a string. You're going to populate it in a particular control. And that's what you're going to do. Every control is going to be populated by the result set information. You're going to get your results in a movie, a Java Bean, right? You're going to take that information from the Java Bean, and you're going to populate all of your controls. That's the way to do it, right? More complex, but more control. Okay. I'm not going to talk about automatic driver delivery. Connecting to the database, we already did that with auto closable. They talk about the driver manager, how it's important to connect the driver manager with the type of connection you're making. And they give an example in the book of Derby as their sub protocol. So again, there's the protocol, JDBC sub protocol, or the database type, and then the database name. And here are some examples of database URL format for different databases. MySQL, Oracle. Notice how it's very similar for all of them. DB2, Postgres, whatever it's going to be. Doesn't matter what kind of database you use. The thing looks like this. And just curious, do you think that you could connect to a Mongo database, a NoSQL database? Do you think they have a driver for that too? And of course, to look that up, you just go to here and you say, MongoDB driver Java, if there is one, right? So Java MongoDB driver is an example, And you can see that if you went to MongoDB, you can pull the you know, kind of a, there might be a driver for Java 3. So I'm using the 3.0 Java driver, right? There it is. And you can download the MongoDB Java driver, and you would install it inside of our database the same way. The only difference is your SQL statements would be totally not working because there is no SQL. Mongo doesn't have SQL statements. It uses JSON data, right? So it's a total different way of doing it, but you could connect to it. The idea here is that, yes, there is a driver, and there's a driver for Mongo for C, for C++, for C#, Node, of course, Node.js, PHP, Python, as you can see, all kinds of other ones that you can connect with Mongo. And Mongo and NoSQL databases are quickly becoming very, very popular, right? Because they produce a flat architecture. But the question that I would have to ask you is this. If you're creating relations with Mongo, which you could, right? You can create your own relations. Why would you use it? There's a lot more work to be done, is what I'm saying. If you're going to make your own relations, you might as well use a relational database, but you can do inner joins, right? If you have a flat database with one table, Mongo all the way, because you don't need to. It's too much overhead for the other one, right? Even a simple flat hierarchy table structure for Mongo would work well. Okay. Let's keep going. Again, we can use our result set for metadata that kind of describes the contents. That's the one way we did. We didn't do it that way, but we did a result set. And they also use, I just want to show you where it is. And we also did the get and set for the results, the result set. We use get methods. And you can also use the whole get object idea to print out you know, kind of a spring representation of the actual column that you're looking at. Because remember, in our way of doing it, when we did a result set, anytime, whenever we looked at a result set, and I'm going to go back to my movie list controller idea, right, just to go through it. And I'm going to look at the first one. This is just our insert one row. Let's look at one of our reads. So here's our read from one row. Read from one row. We have a result set, right? And notice how we say, when we go in here, we go result set.getString. And what we're actually doing here is we're saying, I want to get a column. Here's the column. I want to read from the column name, named name, right? You could also put in a value there instead of a string, because there's an overload for either an integer, like an ID, for which position it is in the row, or a string. You can do either one. And the type is going to be string. But I can also do result set get object, which means whatever it is. Don't know what it is. But that means when it comes back to this, because we're using a Java bean, right? We're expecting a type that's string because we're using the set method that's part of our Java bean, and that's why we're using getString. They match, right? In another example that they have in the book, they don't use a Java bean, right? So therefore, they don't care if they get data back, and so they can use getObject, not a problem. Again, there's different approaches for the same problem, and as there should be, right? Anyone not understand what I'm saying? Result set can get different data, right? And they get it based on the row or the column index, whatever the column index is. You can use a friendly name for the column like I've been doing. So name, description, rating, that's a friendly name for the column, right? The column name is what you're looking at, right? But you can also use numbers. Here, when you use getObject, in their idea, when they were looping through here, and I'm just going to go back to that code for a second that they showed us, when they were looping through and they were getting the results at getObject, they were getting the row number, right? Starting off at the column column 1 as an example, and looping through until all the number of columns they're going through. So each column, and they're doing it for each result set. Remember, when I say result set.next, that's each row. Each row, it's going to read each row in, and as it reads each row in, it's going to print out the rows. That's a different way of doing it. Same thing, right? But without knowing what the column names are called. Because you don't care. You're just reading everything from the database table. So equivalently, this is just as effective as what we did, just using a for loop. Okay. Make sure that I've covered those pieces that you need. Okay, so here's another example where I have a model now. They call this the model, right? Now, again, this is in result set table model. Now, again, notice how they set up the connection, which is final, and a statement, which is final, as one of their private instance methods or variables. And then they have a private result set. They set all this up at the top of their class, right? Inside here, they set up a private Boolean connected to database. This is what you were asking for, Aaron, where you want to have one connection to check that they're connected or not, right? And then what they do is they say, my result set table model, that is the constructor for the result set table model. And what they're going to do in here is they're going to ask for the string URL, the username, the password, and the query. They do everything at once. Now this, I'm sorry to say, I don't agree with. Because this is equivalent to making connections with a different query string every time, right? But why? Why would I do it this way? This is one way of doing it, but I wouldn't say it's necessarily the best way of doing it. Remember, we also talked about type of scroll type insensitive, so you can go up and down the rows with your cursor, as opposed to if it's sensitive, you can only go down, you can only read down in one direction, right? And for MySQL, doesn't care. But for some other database, you have to be explicit and you have to say type is scroll insensitive. Yeah. Okay, like there's other databases that stop you from doing that. Postgres is one of those. Okay, so here's the method that's inside of our result set table model, right? And what they use is a get column class, right? And again, it throws an illegal state exception, which is a totally different kind of exception than what we've been using, right? And basically what it says is if we're not connected to the database, then throw an illegal state exception. Well, you're not connected. And that's what we were getting before. If we're not connected properly to your MySQL database, this is what this will give you that kind of exception, right? And then what it says is in a try catch block, it says my class name, which is a string, is equal to metadata, the metadata that we're going to get from our object, get column class name, and it's going to read in the class name in the column from using the metadata idea. Again, metadata being their solution to. I'm just going to go back up so I can show you where the metadata is being declared, right? Again, is result set metadata, right? Remember the way they did that? Where they can actually read each of the columns and they don't care. It kind of loads it into an object that's friendly with SQL. That's all it is. So that's equivalent to their Java bean, right? Instead of them declaring a Java bean, they're using metadata. Different method of doing the same thing, right? Okay. Again, advantages and disadvantages. This way here, for some people, seems to be a little bit easier. Especially when it does things like column count and things like populating the columns in a console application, no problem. Like get column. If I want to get the column name, what this does is it reads the table, and if you're connected to the table, it reads all the column names and then spits them back out again. Okay, and then here's get row count. That's another method that they use, where they use their you count the number of rows, right? That's all you're doing. How many rows do I have? Spit it out. That's where you're going to return from this get row count. Right? You're going to return an integer number. And then they also have a get value at for row and column. That's interesting. So now they use the database like a grid, right? And so what they would say is if I'm not connected to the database, throw an exception, right? Otherwise, try to use my result set. This is something new. Absolute, look at my row that I entered in +1, and then I use my result set dot get object to look at my column +1 to get the information from that particular row and column. And that's how you would do it. So you can say row, column, I want that data, right? From row and column. Different way of doing it again, as opposed to reading in the entire row. We're reading in entire rows of data. They can look at this row, this column, almost like in a grid pattern, to get that piece of information. Also valid, not recommended. I don't recommend that way of doing it. It's more challenging. I think this is more complex for some people because understanding how row and column data work together, right? Other people will argue, like I was talking to Professor Andre, he thinks our way is more challenging, right? Everyone's different, right? So it really depends on how you look at it. And there's other ways. Again, they're using metadata here. One thing they're also using is this. Because they're using a JTable, they're using this fire table structure changed method, right? And when you trigger this method, you basically are saying that the table structure changed. So now, when I say fire table structure change, the idea is to create a method that triggers the event handler, right? I'm physically triggering it as opposed to triggering it by hand. I'm triggering it because the table data has changed. So when I set a query, I update my table right away. And then they have a disconnect from database statement like you would normally have, Aaron, if you were going to make it so that you have a connect to database, disconnect from database, and they do all their result set close in reverse order: statement close and connection close. They do all that in the order that they open them.
Are they using the same results?
Pretty much, that's what they try and do. So they try and make it so that it's pretty generic the way they do it. So they basically open a connection, they open up a statement, they open a result set every time, and then they on the close they close the result set, close the statement, close the connection in reverse order that they opened it. That's normally how you would do it. Again, if you use an enhanced try block, you don't need to do this most of the time. So that's why I avoided doing a lot of that. So result set, we talked about that a lot. We talked about scroll insensitive. You need to know that. They talk here. They have a good example here of how to use swing to hold your information. I'm not going to go too much into detail about how to do that because all they're using is they're adding labels to the box, and they're doing it programmatically as opposed to by doing it by dragging and dropping like we were showing you. Again, I recommend JavaFX. It's going to be a much better looking application than you make with Swing. Myself, that's my recommendation. Show you some of the other functions here before we move on. Here's the one that Rowset that we didn't cover. So the interface Rowset provides several set methods that allow you to specify the properties needed to establish a connection and create a statement, right? So I know that Professor Andre covered this at length, but we did it a totally different way. So it didn't make any sense for me to cover it. And I'm not going to test you on it. So how would this work, right? Well, notice how we would have this Rowset, which is of type JDBC Rowset, right? And examples of this would work like this. You have a Rowset, and you have a Rowset provider. Like, to me, this is like way more difficult to understand than if you did it my way, right? And what you're going to do here is you're going to say, I can connect to the database this way. I can say rowset.set URL to database URL. So my connection, my DB config that I have in mind, you wouldn't have that. You would have Rowset because you have a JDBC Rowset, and the JDBC Rowset would allow you to connect to the database by setting the password and the command and all the execute stuff right here to connect to the database. And there'd be another type of Rowset, right, that you would use to set your data. So Rowset next, and you would loop through the data in the same way you would get a result set. To me, again, it's neat, but unnecessary. So I'm not going to test you on it. I think you should know about it, but I don't think you should be tested on it. Prepared statements we did to death. I know that Professor Andre didn't do as much in prepared statements. I think he did like, half a class on prepared statements. We did like prepared statements for like 3 classes, pretty much, right? Because this is the way we do stuff. This is the right way to do stuff with prepared statements, right? So, and it gives you some really good examples of things like inner joins, prepared statements with inner joins, how to kind of understand how to do that, interpolation, the whole thing. So it's kind of cool in the database. So it's things that we covered already. One thing I want to skip to, because a lot of this is just code examples. They give you a lot of code examples in the book. And in the PowerPoint, it's going to give you a bunch of code examples on how to do this, right? Way back down on the bottom. One thing I'd like to mention before you go is honorable mention, store procedures. This is what I talked about. So databases that have store procedures, right? They have them in the database, and it's a different way of doing. You can use SQL statements to call store procedures to do your CRUD. Does it all for you, right? And then what you can do is you can use callable statements to do that. They mention it in the book just like this. So I'm gonna mention it to you so you've heard about. You should already know about them from Database 101 anyway. About store procedures. Did you guys not know about them? Anybody? Store procedures. You did. You're learning it this semester.
We learned.
Oh, you learned it already. Okay, good. So it's good. And the other one is transaction processing. And this is the last thing I'll talk about before you go. Transaction processing, the way it works, I know you're running away because you have to catch a bus.
Yeah.
Okay. 2 seconds. Transaction processing, think about a transaction being complete. If I do an update, a delete, a read, anything like that. Any kind of, if I do a read, who cares? All I'm doing is reading from the database. I'm getting a stream of data, right? But if I do an update or an insert, with transaction processing, I can reverse my transaction. So it gives me transaction safety, and that's what it allows you to do. So there's a whole way of doing that. They don't really talk about how to do that, where you can roll back your transactions in the book, but there's a whole other almost advanced methodology on how to do that. I know how to do it, but it's going to take an extra day, and we don't have the day to do it. So really, we can't really go too much into it, but I want you to know about transaction processing and the ability for you to roll back transactions. Okay, and that's really it for me for JDBC. Unfortunately, we weren't able to hit multi-threading today, but next week we'll do a whole treatment on multi-threading to get you guys into it. And again, we'll do a little bit of an application. If we have time, we'll even do a little lab for bonus marks. Okay, guys, take care. See you next week.
Good night.
Take care.